Okay, let's look again at how the image of this mapping, the set of vectors you get from this mapping, are a linear combination of the columns. I talked about that before and I pointed it out, but let's be sure we see how it's written out because it's very important to see this. It looks a little weird the first time you look at it, although we've seen it. Yeah, we've seen it a couple of times already. In any case, this matrix times the vector x1, x2, x3, x4 could be written as first row, first column times x1, that's x1 times the first column, plus x2 times the second column, plus x3 times the third column, plus x4 times the fourth column. Okay? If you add these together, what do you get in the first row? You get x1 times 1 plus x2 times 1 plus x3 times 1 plus x4 times 1. You just get x1 plus x2 plus x3 plus x4 in the first row. Well, if you multiply the first row by x1 through x4, that's exactly what you get, x1 plus x2 plus x3 plus x4. Okay, what do you get in the second row when you multiply these matrices through by the x1, x2, x3, and x4, these column matrices, or vectors if you wish. Okay, in the second row you get x1, you get 2x2, you get x3, and you get 2x4. Well, if you multiply the second row by this column vector, that's what you get. You get x1 plus 2x2 plus x3 plus 2x4. And you can check out that the same thing is going to happen to the third row. Okay, so this product equals this. Now, x1 through x4 can represent any vector in your original space in R4. So any vector that you get over there in R3 has to be a product of the matrix times one of these vectors, which means that anything you get over there in R3 as the result of your mapping is going to have to be a linear combination of the columns, because that's exactly what this is. It's a multiple of the first column plus a multiple of the second plus a multiple of the third plus a multiple of the fourth. Okay, so this is a linear combination of the columns, and it's in the column space. It's a member of the column space because it's a linear combination of the columns. Okay, these linear combinations span the column space. Since x1 through x4 can have any values, this can be any combination of the columns. Okay. Now, we have a statement here that's false. I haven't yet corrected it. I said any vector t times 1, negative 1, negative 1, 1 is a pre-image of the vector 1, 2, negative 1. Here's the vector 1, 2, negative 1. Here's the set of pre-images of 1, 2, negative 1. Okay? And I have a statement down here that indicates that that pre-image is a subspace, and I've already stated that it isn't, so I have to fix this. So it's any vector 0, 1, 0, 0. Yeah, I don't have space for that T there. Now I gotta smudge it all up, make it look bad, and I don't have white chalk handy, but here we go. Plus T times this vector, okay? This is a correct statement. This still isn't. But now your 1, 2, negative 1 is the vector 0, 1, 0, 0 added to some multiple of 1, negative 1, negative 1, 1. Now we saw that at the beginning of the first video in this series, so for this document. Now I say the pre-image of 1, 2, negative 1 has dimension 1 and is spanned by this thing, and that's totally incorrect. So I'm going to put a big old X through this. I will wash that off the board shortly. I can say that the pre-image of 1, 2, negative 1 is 0, 1, 0, 0 plus, I'm going to say, of course it's this, T times this, but that vector is in the null space. This vector spans the null space. So it's like you've got the null space here, and let's color the null space the same as we let's just say that this little blurb here indicates the null space. This vector is like the null space, but to every vector in the null space we add this one single vector, and then we get a set, not a space, but a set that maps to the vector 1, 2, -1. So this is in a sense kind of parallel to the null space, but it's moved over by this vector. It's a very interesting construction, and we want to kind of keep that in mind. I'm going to talk about the general transformation from Rn to Rm, but I'll do that in the next video.